Hello everyone, how is it going? This is Benjamin from the Zephyr project. It's been a while. I mean, yes, we're back for Tech Talk, but I think the last Tech Talk was effectively Zephyr 4.0 release party. So similar to what we're doing today with 4.1, which we just released like 10 days ago or something. So that's what we're going to cover today. Hopefully we will start lining up new Tech Talks really soon. Like I said, it's been a while, but I'm sure we can find some good topics. If you are interested in presenting, feel free to reach out. I will be sharing some links below in the banner in a minute, so that you can reach me if you want a quick round of intros, or at least like quick round of shout outs from the audience. Please do say hi in the chat, whether you're joining from LinkedIn like Joel or from YouTube like Gigi, whoever. Welcome both, welcome everyone. This is going to be packed with content. So I'm joining from France. How about all our guests that I'm going to be bringing on stage just today? Just a few faces among the very many, almost 700 people who contributed and participated to Zephyr one way or the other, at least code contribution wise. Let's go screen clockwise. We have Robin first. Who are you? Where are you joining us from?
Hello, I'm joining you from Uppsala, Sweden, where IAR is based. We are a compiler vendor, and we have recently been working on Zephyr support for our toolchain.
Nice. Next, we have David.
Hello, I'm David Brown. I'm coming from near Denver, Colorado, where it's like -4 this morning. So nice fun time here. I'm with Lenaro. We're not really based anywhere, so we're all distributed.
Nice. And you're going to be covering Rust mostly, yes. I guess, today, because it's one of the big news from the release. He said clockwise, so I guess Fabio is next.
Hello, hi. I'm Fabio Baltieri. I'm based in Dublin, Ireland. I work for Google. I was a co-release manager with Benjamin for 4.1.
Nice. Next, we have Titouan.
Hi, everyone. So I'm Titouan. I'm from Belgium, where at least we have some sun, and it's 18 degrees outside, so that's nice.
Nice. Last but not least, we have Anas.
Yeah, hi. Anas Nashif from Montreal, Canada.
Great, thanks. All right, and we have lots of new faces in the on the chat from lots of people joining from LinkedIn, I guess, today. Hello, Johan, Luis, Philip, Shaheen, etc., etc. Please keep bringing those greetings. It's always nice to see. So yeah, we are here to talk about the release, answer all the questions you all might have, whether you're wondering how to, you want to learn more about some of the things that actually made it into 4.1. You're interested in learning more about what's sort of like part of the roadmap in terms of going even further in terms of what new features, etc., landed. But yeah, let's use the release notes as sort of a guide for the discussion. We'll be, just for the sake of having some kind of structure, we'll probably go in the same order as in the release notes. But I think, to me at least, all those sort of top-level bullet points, they're all equally important, like really, really interesting stuff that was worked on and made it into 4.1 release. Lots of performance improvements, so we're going to talk more about that. IAR, Robin mentioned, is with IAR, and he can tell us more about that. Rust, long awaited. What does that mean? And I'm sure many of you, that's why you're joining. Or maybe you're joining to learn more about USB-MIDI. So Titouan has been pretty busy. I already know that one thing that I want to ask Titouan, so please can already be prepared to answer that one, but I'm actually wondering how much time you actually spent on this, because it's really a lot of lots of work that went into it, and that makes for really, really cool new feature. And then lots of other things. I mean, the release notes are actually really long. There might be some things in there that you, the audience, are interested in learning more about. So just let us know. We can already line up your questions and comments, actually. Yeah, but let's start maybe with performance improvements. I mean, Anas, you will probably be much better positioned than I am to talk about that. But I think this is something that actually started even before like this sort of the last 4 months. Started well before we started to work on 4.1. Yeah, what happened? What does that mean for folks? And what's next? Also, maybe.
Yeah. So, hello everyone. I can hear myself. That's
okay. Not sure we can do anything about it.
That's Fabio, probably. Yeah. No, Fabio is muted. Yeah, that's funny. Okay, so basically, just like this is so annoying. Yeah. I can't really think when I can hear myself in the background. Is everybody muted?
Yeah, I really don't think we can do anything about it.
Yeah.
From what I can tell. So you will have to.
Okay, I'll try to ignore what I'm not to listen. Yeah. So just speak. So basically, just like Benjamin said, I mean, performance in Zephyr, obviously, we are on RTOS. I mean, people are coming and using something like Zephyr for various reasons, performance and being responsive and real time, close to real time as much as possible is one of the reasons why people look at that. Yeah? Otherwise, you would just go and stick with your bare metal implementation, and since actually Zephyr was started almost 10 years ago, I mean, if you look at the history, and I actually double checked, I mean, we had like benchmarks and we had all kinds of tests and tools to measure performance, mostly not, to compare with other RTOSs, but actually to keep track of the performance as we changed, as we, evolve. So we have like a few benchmarks in the tree that we have been running over time. And when we do major changes to the kernel, we actually go and verify that we didn't break any any metrics and so on. So this is something that has been we have been doing for a while. Not only performance, we have a few other metrics. Like we are tracking, footprint as well. We are not only tracking performance of the kernel itself. There are like a lot of components, like for example, crypto libraries and so on. We have also benchmarks to measure, encrypting, decrypting, and so on. So, sometimes this is like a way. It is a way for us to make sure there are no regressions when major changes, when overhauls are done. But for day-to-day development, if I'm a kernel developer and I'm changing something in the basic workflows and algorithms of how things are done, I want to verify that I am not breaking anything. So we have been doing that for a while, and a few years ago we did some comparisons with other RTOSs just to make sure that we are in the same ballpark and we are not far behind. And this is usually the first question that comes when somebody is interested in using Zephyr, is that, hey, can you show me how better performing you are than this RTOS or that RTOS? So we had actually a few, and a few years ago, Peter Mitzes, who's one of the kernel maintainers, also worked on a benchmark suite based on the benchmarks that we had, that is actually hosted under the Zephyr project, where we compare with other RTOSs. And a few RTOSs are supported there. So it's abstracted in a way that, it's the same code, for scheduling and creating threads and so on. And it's abstracted. So you can actually go add an abstraction layer and make it work with FreeRTOS, with RTMS, with ThreadX, and so on. So that's something so just to show that we have been looking at this. But it's not something we looked at like we are not trying to be play this game of marketing and showing like keeping track and showing that, oh, we are the best, we are the most performant, etc. Because Zephyr, as you are all aware, is not just a kernel scheduler. It's not just an RTOS. There are so many aspects in Zephyr which actually deserve a lot of attention and focus. Footprint, for example, power management, adoption. So there are so many things, security, safety, etc., etc. So it goes more beyond just being fast. So anyways, making it short, last year, as many of you are aware, I mean, there was a benchmark or a report was published with a few of the RTOSs out there compared using thread metric, which is a benchmark that has been actually part of ThreadX for a while. I remember first looking at thread metric, the benchmark, 5 or 6 years ago. So there was a benchmark, a report comparing various RTOSs, and many. I mean, when it was first published, I mean, there was a lot of noise in terms of, oh, look, Zephyr is not performing there. I mean, the numbers were not really in our favor, and we looked at that immediately, and we noticed immediately there is something wrong, in some of the areas. Basically, hardware stack protection was enabled, and that's something that really degrades performance because you spend a lot of your time when context switching, at least, verifying the stacks. So we actually connected with the author of the report, and there was another release, but we still actually had like a few areas where we could do better. Yeah. Can you share the screen now? I mean, I don't know who can share. Do you have to put the screen there? Yeah. So this is actually something that you can find on GitHub discussions. Somebody please can post the link or something like that. I mean, it's already, I'm just, using the image that is in the GitHub discussion. And that just gives you an idea about where we are and where were we and how and what our plans are. So if you look at the bottom line, sorry, I mean, it's the font is really small, but I mean, the colors the length here is like the most important. The numbers don't really mean anything. And so basically ThreadX, we were able to reproduce the benchmark using ThreadX and using exactly actually the same hardware used in the report. Yeah. So if you look, this is ThreadX. I mean, it's leading. Yeah. And the report itself was done with Zephyr 3.7. So if you look at the second column from or row from the bottom, that's basically kind of reproduce what was reported after the second revision, at least, of the report. So we spent a lot of time analyzing, and without changing anything in the code, we were able to identify a few areas, a few configuration options that were not applied, that help performance in general. So just one key option that we have is in Zephyr we use bcolibc as the default C library, and this is something that is integrated in the SDK, so it comes pre-compiled with the toolchain. Sorry. And the way it is built, and integrated, it's optimized for footprint. Yeah. So even if you actually go and enable optimization for speed, it still uses the libc that is optimized for footprint. And this is something that we are basically trying to fix right now by providing 2 binaries in the SDK. But basically, that already contributes, to the fact that Zephyr was not really performing well in some of the benchmarks. So that is something we fixed, because as many things in Zephyr, you have different ways of doing things, and we were able to make the change or to basically build bcolibc from source and optimize it for speed. So that actually gave us a boost, at least in the benchmarks that depend on libc. Yeah, or you can decide to use new lib, then it actually would also give you the same results, better than what was reported in this benchmark report. Yeah. So, and there are like a few other things. So you can see like in the third, this is like just like applying some configuration options and optimizing for speed. So that gives us like a boost. But obviously, looking at the benchmark and the way this benchmark works, which is very unique in the way it does things. So it does like a few things, and that would be measured, but it does not cover the whole, everything an RTOS does, and it does it also in very unique ways. For example, the context switching benchmarks would use suspend and resume, so to context switch, not something that you usually do. Yeah. So basically, we looked at how it's done, and we looked also our code, and there is a few things that we identified. We also identified that at some point last year, some code was merged, at least on the ARM architecture, that degraded the performance, and that was not functional change per se. That was just moving code from assembly to C code, to make it readable, and that gave us there was a penalty there. Yeah, so that's something that we reverted, and there were like a few other changes in the kernel code itself. For example, inlining code, inlining functions, or inlining heavily used functions on the hot path helped a lot. And the reason they were not inlined originally was the fact that when you inline, basically your code grows and doesn't fit in some boards and so on. So we started like taking this path, and there are like a few other things in the kernel that we optimized. And as it was showing on the picture, if you the top bars there shows you that when it comes to scheduling, like preemptive, cooperative, synchronization, we are doing actually really well, and we are actually performing better than ThreadX, which was the baseline here. Yeah, the areas that we need to work on, or actually contributing to Zephyr not being the first year, are actually related to memory allocation and copying message, and these are two areas that we are looking at. The fact that we rely on libc for this, so we don't hand code our own memory copies and stuff like that. That's one part. In ThreadX, for example, that's a little bit different. Yeah, and also the way we copy messages, at least in the current implementation, contribute to that. But that is something that we are looking at. But I think this is not really the important stuff. Is like when you are doing at least when it comes to an RTOS, are really like the context switching, cooperative, preemptive, synchronization, and a few other things. Mutexes, other synchronization primitives that we have in the tree, and we have like a lot of benchmarks that cover that mostly. Yeah. So to make it short, since the release of the report, we had two releases, 4.0 and 4.1. In 4.1 we are actually doing really well in terms of like comparing with commercial RTOSs out there, considering that the fact that Zephyr actually is more than just a scheduler. Yeah, so there are so many things happening there. Yeah, and we will continue to improve things and make things faster. We have a few ideas on how to improve things. There will be actually a more detailed analysis and explanation of the things that we addressed and we are going to address. Will be part of a blog that we are working on right now. So we will publish that and make sure everybody knows, how to find it. And we will start tracking this data. I mean, the benchmark itself is not something you would use to benchmark hardware or to benchmark to advertise. I mean, benchmarks are always tricky. I mean, this is good. It is only useful, when comparing with other RTOSes. That's not something I would use to show that my hardware is faster or something like that, because it really doesn't cover like this type of usages. Yeah, I mean, there are many other benchmarks out there that can focus and can be used to benchmark hardware. It's good just because you can run it and you can use it, and people have been using that on other RTOSes, so you have something to compare. But it's not something I would depend on or depend on it only or exclusively to manage and track performance. Yeah, so we have our own benchmarks for that. Sorry, that was probably a little bit longer than I thought. If there are any questions, please put that in the chat. Yeah, I don't know. Were there any questions, Benjamin?
I had muted myself because you had those echo issues. Yeah, really quick, because yes, that was a long but important discussion. Someone is asking, Vinay is asking, are there any plans to backport those performance improvements to LTS? I guess my short answer would be, are you really concerned? Like, is this a bug for you? Like, are you really seeing performance issues that are actually preventing you from doing whatever it is you want to do on top of LTS? Then that's, and depending on the answer, then I guess the longer answer is, I don't know, Anas, what's your take on that? Like, would we typically consider a performance fix something that's effectively worth backporting to an LTS? It's an interesting question, I think.
Well, yes, actually, we ported a few of the fixes, they were ported already, yeah.
Okay, so we do consider them bug fixes.
Yes. I mean, it depends. I mean, some of them, like the ARM context switching, issue there, that was backported, yeah. So,
okay, cool. Yeah, and I guess, I mean...
but not everything, obviously. I mean, a lot of the things
and just, I guess in general, if folks like Vinay or I think Bruno was also echoing the comment, just in general, when there's anything that gets fixed in between LTSs and you really have a strong opinion on having it available on an LTS, just be vocal, right? I mean, we have GitHub issues and Discord and whatnot. Like, at least let us know. Like, if you feel like something is not going to be backported and you would really want it to be, just say it. Is the starting point. Cool. Moving on to and if there's more questions, please do queue them in the chat, whether it's on YouTube or LinkedIn. Let's move on. Kind of related, I guess, sort of, but some good work has been done on adding support for the IAR compiler / toolchain for ARM in Zephyr. So, Robin, do you want to tell us a bit more about sort of like what's the status of what's available for people trying this out in 4.1? And like I think it's pointed out here, it's considered experimental, which I guess means that it can only improve and more will be available in 4.2. So you can maybe tell us about what's coming, right?
Just a quick introduction. IAR is a compiler vendor. We have been making C compilers for 40 years, and we're best known for our highly optimized code on very small microcontrollers. We are functional safety certified as well, and we are used very much inside regulated industries. And I think this is something we will really add to the Zephyr project. but for more details about what's in 4.1, I call it experimental, and I think that is a good start. It means that the kernel acceptance tests pass on a few select boards on Cortex-M. So this is Cortex-M only, and we haven't tried all the vendor hardware abstractions layers either, but some of the biggest are tested, and that's what we've been focusing on. This has been done in our work has been like coming from two different angles. We have both added support for many GNU extensions inside our compiler, but we have also been fixing up Zephyr and making it more following standards and trying to remove some of the worst GCC GNUisms inside the Zephyr. The hardest part for us has been what does it really mean for a toolchain to support Zephyr? Because there is so much out there, and we really need to have some kind of discussion what that means. But for now, we are working mostly on the linker side. That has been the most difficult for us because the linking process inside Zephyr is either LD skeletons or it's generated from CMake, and these systems are entirely in parallel and get out of sync easily. And this is something we will have to work to try to solve to be able to continue supporting our own linker. And that also means that some features that are in this CMake linker that are not supported inside the CMake linker generator are not supported with our toolchains, like config user space is not supported, for example. We also have some known issues that we are looking to improve. We currently have no C++ support. We don't expect it to be really difficult, but we just haven't figured those parts out. We also need to make sure that we integrate the C libraries better. Right now we are using minimal libc because that was the easiest part, but easiest to get running. But we will need to start to look into getting our own C library, which is very optimized in some sense. So maybe that could be a nice thing to get in. We will also be looking at adding more architectures and things like that, but those plans are not finalized yet, so I don't want to promise anything there.
Okay,
did
cool.
I answer it?
Yeah, that's great. I don't see any questions lined up for this topic specifically, but there might be later. So yeah, and there's a question from Andre on YouTube regarding best practices and stuff, which I'm saving for later. But that's actually a really really good question. Let's see. Let's put back the release notes on the screen. Kind of halfway through, both time-wise and topics-wise. This one, I think, might require some time. I hope we won't go over time, but yeah, let's switch to David, basically, to talk about, I think you've been the man behind this, but there's been also quite a few contributions from the community already. So this is great. This is also, I guess, we can call it experimental, or at least it's optional in the sense that it's something that is sort of opt-in. If you want to start playing with Rust in Zephyr, it comes through an optional module, and maybe you can talk more to what that means. But yeah, give us a quick rundown maybe of what's the history there. That also, I'm sure, is something that didn't start 4 short months ago. It's been probably much longer time in the making. Yeah, what's there? What's coming? What did you learn? Why should the community care?
Sounds good. Thank you, Benjamin. So yeah, I've been working on it about 6 months, kind of in earnest, as in it's my full-time job. So the basically, it's kind of been a desire for a number of years. I've played with various little things and done little demos at previous tech talks, but then if we've had this opportunity, basically somebody willing to pay for the work to get this kind of core support for Rust into Zephyr. I guess a good question is, what does that mean? So if you're unfamiliar, Rust is a programming language. There's an emphasis on memory safety and a lot of other aspects too, but that being probably the biggest driving factor motivating people for it. And so this effort is to get the ability to write applications in Rust for Zephyr. There's no effort that's gone into like drivers in Zephyr, or Zephyr drivers that are written in Rust, or like replacing core functionality or anything like that. If you want to do that, enjoy the conversations with the TSC that you will create from that. But this is an optional module, as you mentioned. It is also, I will say, experimental. The most notable consequence of that is the API is not set in stone right now. I started going through some improvements to the API very recently since this release, and realizing that, yeah, we probably don't want to go through a whole deprecation process at this early stage with this, and we'll just fix the APIs as necessary. Do you want to pull up the documentation then, Benjamin, for this, and then I can share a couple things if necessary. The basic idea is I've added support through, so it's an optional module. There's a section in here on what you need to do to enable the module in a given configuration of Zephyr. And then inside of your application, and there's a couple of samples in the module itself, you basically create a small CMake file that says this is a Rust application. You can include C code in it as you would ordinarily as well. The goal being that you don't have to, that should be possible to do everything you need to entirely in Rust. So Rust is traditionally built with a tool called Cargo. And because this is applications, I leverage that same tool to build your application. Cargo does a lot of the things around dependency management. In this particular example, we're pulling in Zephyr, which is a crate provided by my module that implements the interface to Zephyr. And then I'm also pulling in the standard log crate, which provides logging. And so this particular example, this hello world that this is taken from, uses logging to, if you look under source, what we effectively are able to do is say hello world from Rust using Rust's logging mechanisms. There's going to be a lot of questions that come up occasionally about unsafe. Rust requires things that are marked, that are considered unsafe from the language's memory safety guarantees, to be marked with unsafe. And because Zephyr is a large C code base, there are some instances where certain constructs are not considered safe from Rust's perspective. And there's still some debate going on as to what actually qualifies as that. In this particular case, initializing the logger is something that we, and this can be improved. There's a lot of instances where we change a static safety check into a dynamic runtime check, which allows it to be used safely. The main thing is that this can only be called once. If you call it again and your target doesn't have atomic instructions, it's unsafe. So there's some complexity behind that it probably shouldn't go into. But nonetheless, what we have at this point, if you go back to the docs, scroll to the bottom and click on the API documentation. So at this point, I would describe what we have as a pretty solid interface to the kind of core Zephyr functionalities. So threads, synchronization, work queues, semaphores, there's an implementation of channels, timers. this kind of stuff is all there. There's not very much in the way of device support yet. So that's kind of the big thing that needs to be done next, is making Rust-friendly interfaces to drivers. And I'm working on some of this. What is done, though, if you click on that device tree, so this is actually an instance of where it shows that a particular build depends on your Zephyr project configuration, the kconfigs, the device tree that's there. When you build an application in Rust, it converts the device tree into a tree of Rust modules inside of these. So if you pick this particular one, doesn't have any interesting devices in it.
Yep, I was looking for an LED of some
click
kind
on the
with
flash
GPIO.
device. That's one that's at least there. And yeah, you can go there. And no, I guess it isn't there. So this is a consequence of somebody complained that we were building based on one vendor's hardware for the docks, and so we changed it to a QEMU, which has no devices in it that are interesting. So I don't even know what device this is generated for. That's kind of interesting. Regardless, the device tree will show up here, and when we have a supported device, there will be a function in there called getInstance that you can call once, which will give you this nice Rust handle with methods that can be invoked on it to use that particular device. There's, I guess the other thing to cover is, one thing I will point out, this is very much in the middle of this work. We're not by any stretch done. And the main consequence I would suggest is don't try using the module that's in the release. If you want to actually actively work on this, join the Discord channel, have discussions with us, and you probably want to use the code that's in the current release of the module, the main of the module. So as far as work coming up, there's some changes that I'm making that are actually already there. One of the interesting ones is the way you create threads was a bit clumsy in the code as it is in the release. I don't know if you want me to share this, or I do have a terminal window up I can share if it lets me.
Sure, yeah, if you can.
I don't know what it's going to do. I will, let's just leave it for what we'll say. Effectively, I borrowed some examples of how this is done in other Zephyr project or other Rust kind of embedded projects. And now you just create a function at the top level and you annotate it with a Zephyr thread where you can specify a stack size, possibly a pool size if you want more than one thread with the same function. And then in your code, you just call that function and you get back this handle that lets you do things like set priority and some other things on the thread. And then you can just start the thread and it just runs it. There's that. Then you get this handle back that lets you join the thread and then you can restart it with different arguments, that kind of thing. Another interesting thing that's kind of in progress is async. And that's much more broad of a topic than we really have time to cover here. What exactly async is and why that's useful. Effectively, the Rust language lets you mark code as async, and then in that code, whenever it needs to wait for something, the compiler basically converts your what looks like regular code into a state machine that implements that. And then those are basically the interactions between these asynchronous tasks happen in the context of a single thread, so that it basically gives you a little bit of advantage. The biggest advantage is that it doesn't need stack space for each one of these tasks because they're state machines. They run to a stopping point and then they return. So this support is kind of just beginning there, and I will, be going further. I've implemented one call to a driver that is async so that you can see what that's like. I should probably go into some of this question here.
There's a question from Bruno, I think kind of related to the unsafe thingy, and like, I mean, is there an expected benefit to add Rust compatibility in Zephyr, or is it just because we can? And I mean, you kind of hinted at what some of the benefits can be, right? In terms of like programming patterns, and yes, there's the whole unsafe discussion, but yet it can help make some other aspects more readable, or like remove some boilerplate, I guess, right?
Right. So there's, I think, a couple of ways you can answer this question depending on what the focus is. I'm seeing this question as, I'm a Zephyr developer, why would I want to use Rust? Versus I'm a Rust developer, why would I use Zephyr? And I think both of those have good answers. In the case of I'm a Zephyr developer, why would I want to use Rust? A lot of that is just, first of all, there's memory safety, which is a really big thing. The notion of safety and security is a really common thing, and a lot of the exploits, a lot of the vulnerabilities that we get reported against Zephyr are because of memory safety issues, buffer overflows, these kind of things. So there's a kind of a built-in advantage of a language. It goes deeper than that. Rust actually has fairly rich ability to abstract, to build abstractions that don't end up costing when in the generated code, that we can have things that you do that seem like higher level abstractions that are compiled away. And that there's a definite advantage to that. I probably won't answer the question in the other direction of why a Rust developer would want to use Zephyr, other than the basics. Zephyr brings a lot. We have a lot of devices. We have a lot of interfaces, infrastructure available for an application to use that would then be available for the Rust developer.
Yeah, Tom's question I think is also interesting, and the way I understand the question is something like Rust, and actually IAR and like different compilers and tools, etc. That can also sometimes help point at some holes or issues with the way some of our APIs are designed, or like the way our C interfaces are maybe not as concretely defined, to quote Tom, as they should be. Have you seen a bit of that?
Well, I've definitely run into it in several instances.
There's a whole device tree thing.
So, well, there's a whole ball of wax behind device tree, and a lot of discussions going on there, where the device tree doesn't completely define an interface, and pieces of it just exist in how a particular driver happens to implement it and where that gets connected together. But a lot of other aspects I run into are where all of the edge cases are not described in the comments for a particular API call. Sometimes it's even not obvious this driver has a callback. Is that called from interrupt context, or is it called from a worker? Or is it even defined? Something simple like the GPIO interface. Is it safe to call different GPIOs from different threads? The best answer that I've gotten is maybe, and it's kind of an implementation specific. But then from a Rust point of view, where the language wants me to decide when I'm implementing that interface, is that thread safe? You know, we get these handles back, and I had initially done this to where it wasn't. There was this thing this token you had to pass around, which, by the way, generates no code, that would make the thing completely thread safe. But then it turns out that you can't wait for a GPIO to go high and then use any other GPIOs while you're waiting. So that interface is going to have to change, and we'll basically just declare that when you get GPIOs, that's unsafe, and you need to go figure out if your hardware lets you do that. In my experience with the MCUs that I do at least basic GPIO operations do tend to be thread safe, but it gets funny when you start changing the configuration of the pins.
Yeah, maybe one last question, maybe real quick, and I'm sure there will be more lining up. Chris is asking, in terms of performance, do you have any sort of like feedback, specifically the example you took with using async versus using Zephyr's built-in state machine framework, possibly? And there's also a question about whether alloc is supported.
So I haven't looked at the state machine framework at all. I did initially implement an async executor that used triggered work queue items. I've ended up not going in that direction, mainly because they're not compatible with async in any other Rust code. And I think the main benefit of using async in Rust is that there's all these libraries out there of things that you can just now use that just work. And with that particular implementation didn't give you that opportunity. Also, performance is not great with that. We're basically pulling in the overhead of everything and adding them all together. So you get the async executor making decisions about what to run in addition to the Zephyr scheduler overhead and the Zephyr primitives. But basically, if you say pull in an external semaphore implementation written just for Rust async, which is completely OS independent, it just works on anything that implements async. Context switch overhead running on a single thread is on like a Cortex M0 is about half of what it is to do a semaphore between threads. And then if you did async, so like an async executor, you can run different executors on different threads and you can be in different contexts. The overhead between threads ends up being about the same because it's kind of doing the same thing at that point. I don't know if that completely answers the question. The other aspect of that question is alloc supported. Yes. Currently, it goes down and if you enable, there's a kconfig to enable it. I am trying to move away from depending on it for the Zephyr primitives. There's a lot of complexity behind that, namely because of some very different execution models between, mainly whenever you have a queue inside of a Zephyr object, it assumes that that object cannot be moved in memory because it contains pointers back. And Rust by default kind of likes to just freely move things around. So you have to put some effort in there to make sure that it doesn't do that. Usually the easiest way to do that is to just declare them statically, which is commonly what people do anyway with C code. They don't usually allocate semaphores, but it works. So,
right. Okay. I think there's actually a few more questions, which actually my question or my comment to you, David, is look at your calendar. When is the next Wednesday or Thursday you're available? And we just do a tech talk where we specifically dive into Rust in more details, because there's certainly, you can tell from the comments that we can
we can
probably dedicate an entire hour to that, and you will probably have more to show in terms of what you've been.
And join on Discord. There's a,
Discord is really, really active. I think I put the link earlier. If you're not on Discord already, chat.zephyrproject.org is the sort of like the shortcut to get the invite. And Rust, hashtag Rust is really, really active. All right, we have a few minutes left to cover, among other things, the work that Titouan has been working on. I'm going to pull your slides, Titouan, from I think it was at FOSDEM about a month ago, where you were sort of premiering the work you've been doing on USB-MIDI. Tell us a bit more about what's the story behind that, and maybe what's also in a few seconds or in a few sentences rather, what's your journey with Zephyr? Because for many of us, you were sort of like a new name, and yet you bring us really, really cool and complete feature. So would love to learn more about that.
So yeah, this MIDI class started actually as a project with a friend. So if you go like I think the next slide in the presentation, we see like the whole journey. So all the slides are condensed here, but you can see some prototypes, some wires and cables on the bottom left, and then going up to the actually device you have on the larger picture. So yeah, the idea was a friend who reached out and wanted to build a controller, a MIDI controller, and we just ended up. He's a musician, so not a programmer at all. On my side, I'm kind of a geek, a programmer, and so I just wanted to do that. And I just heard about Zephyr just before, and so this was like a pretext to learn Zephyr. So yeah, the idea is that I tried things. I actually worked on that for a very long time, but working is not the right word here. It's more I fiddled a lot, and at the beginning, MIDI was only a very small part of the project. This was also like connecting all the stuff, trying to figure out how to use different devices and how the whole Zephyr work. And I had a few different implementation over time. So at first, I had some trials with the old USB stack, and I got with that for a few years, completely out of tree and just like fiddling on my own laptop. And then, at some point, I think on the Discord, I saw someone who said, "Hey, is there a MIDI implementation?" And I just decided that I could grab everything I had and trying to port it on the new stack and bringing it into Mainline. So this is what I did. The idea is that I think there's quite some enthusiasm about that feature because, like Benjamin, you made like quite a few funny demo with that. I remember like I opened the PR and 3 days afterwards you had a demo running as a piano connected to your computer, which was very fun to see. And then afterwards there were some people building other stuff. I saw like a guitar pedal controller and other stuff. But mainly compared to all the other thing we just saw in this tech talk, it's I would say on the funny side of the cat. Not really a core feature, but probably something where Zephyr can leverage a lot to bring new devices. So actually, this implementation is on MIDI 2, which is quite a new thing. It's been published in 2020, so it's very recent compared to the MIDI 1, which dates back to the 80s. And MIDI 2 has some improvements like, as you can see on this slide, the USB topology is much easier than the old MIDI 1 implementation. But also you have more precision, and for people who are not working with Western music, so where you have notes outside of the piano keyboard, I would say, MIDI 2 can support that, which was not possible with MIDI 1. So support for USB MIDI 2 from the host. I know that the Windows driver is open source now, but I don't know exactly if that's already mainline, like deployed on your Windows computer. On Linux, it's supported, but if you have, I would say, an old distribution, or at least something that packages old things, old kernel configs, like on Debian, for instance, you may not have the MIDI 2 support enabled. And on macOS, it's supported. And so, as this is a very new thing, I think there's also the potential for Zephyr to shine in because, we have lots of device drivers, lots of API to connect to whatever the world has to offer in Zephyr. Then it's a good idea to have a MIDI stack so we can actually connect the world in MIDI to our computers. And during, I wouldn't say during FOSDEM, but around the time of FOSDEM, there was also the NAMM, which is a music conference. And at that conference, they announced the new UDP MIDI 2 protocol, so MIDI over network, which, it can be more useful than USB in some kind of circumstances. And so maybe that will be like my next adventure in Zephyr, like trying to add support for the MIDI 2 UDP transport, which is very completely new. So yeah, that was basically the journey. You can read the samples. You see, it's very easy to use. You just add the MIDI 2 device in the device tree, and then you can simply exchange some musical notes with your host, and that's pretty much all.
And it's both ways, right? It can be either the Zephyr board or whatever sending notes to a synthesizer or like something else, or the other way around. You can, not sure about what's the exact terminology. I keep sort of like mixing up terms, but you see the idea. It can be really both ways, which the sample code demonstrates. So cool. Thanks for that. Let's I don't know, let's bring everyone back on the screen, sort of like big time. Was there anything else you all? I guess I can briefly maybe show, and I think we made some noise about it, so hopefully you did not miss that. But some work has been done or keeps getting done around documentation. In this release cycle, it was mainly focused around board documentation, extending on the existing catalog we have, allowing you to pick a board by architecture, by vendor, etc. But now you can also pick up based on the hardware capabilities you're interested in. You want a board that has an LED that has, I don't know, like very basic features in that case, but a RISC-V board that has LED serial. It turns out that out of the 22 that apparently support that, there's a few new boards that were added in during the release, like this guy right here. I think it's like 10 cents of a dollar on AliExpress. A really tiny 2 kilobytes of RAM RISC-V based MCU, and as you can see here, and that applies for to many other boards as they transition to this new system. The list of supported features as per what's indicated in the respective device trees of the SoCs and the boards is listed here. Give you a sense of like what IP, what peripherals are available, and more importantly, what peripherals have a corresponding driver in Zephyr. So most likely everything you see here, especially if it's green and like enabled by default, you can just readily use and start running code samples, etc. So that can really. I took a really stupid, I guess, example where I was only looking for LED and serial, but you might likely be interested about things like, I don't know, a board that has LoRa and a display. And yes, some of the things you see in the UI could probably be improved, but yeah, ARM-based with an LED, LoRa and display. Apparently there's none. So if I get rid of the display, at least there's a few more. So yeah, do you want an STM dev kit? Do you want rack/Nordic based? So that's, I didn't click on the rack. Right, and among the many features available, LoRa is available on the board. It has some sensors as well. Whatever, you get the idea. There were some questions regarding safety, which I'm going to bring one from Black Rhino over there, following up on the, was triggered by the IAR discussion, but short answer to the question, does Zephyr plan to support certification? Specifically 61508, I believe, is the one that's immediately sort of like on the radar. Join Discord as well, the safety channel on Discord. I think Tobias, our safety architect, we saw him earlier, is watching us today. He will be happy to guide you, just like many others. We have a repository where we start documenting and gathering all the requirements for the Zephyr kernel, so that basically we get to a point where we have all the artifacts required to go and get Zephyr certified or certifiable. Let's see, there was, I think actually someone was answering just that.
Yeah, it was me just answering.
Exactly. So cool. Great. What else? besides MIDI, other plans for other audio specific? And I know we will be running out of time. Fabio, make sure to chime in if there's anything from your side. Of course, besides MIDI, any plans for other audio specific features? Actually, maybe Titouan, I think you were working on some like audio sound generation sort of stuff, or was that just like random experiments?
So I just plugged into the existing audio subsystem from Zephyr. So there is already something, but yeah, it was just for a demo. So I had this board where I just implemented the driver for the audio codec, so to generate some sounds on the jack output. But that's all using like the I2S and the audio stack from Zephyr, which is already existing. To which extent does that go? Yeah, that's outside of my league, I would say.
Yeah, and I think we were discussing, I don't know if that makes sense, but given we have support for things like CMC, DSP and stuff like that, like generating sound waves and like harmonics and whatnot, there might be some areas worth exploring. So Adrian, others, I guess, given we are sort of like slightly going over time already, the call to action for everyone is like, if you ask the question and we didn't get a chance to, we missed it or didn't get a chance to answer it, join us on Discord. Like some of the Rust questions we didn't get to, you can keep discussing on LinkedIn or in the YouTube comments, of course, and subscribe, etc. Bring the thumbs ups, but the community, the live discussion is usually happening on Discord. So please do join us. And Andre, I think I kind of promised I would come back to that. You commented a few minutes back. Is there other plans in future releases to bring more code samples that demonstrate like best practices in terms of how to structure your code base, etc.? Short answer is yes. Slightly longer answer is look out for example application on GitHub. In the Zephyr project organization, we have something that's kind of close to what you're asking. We need more, of course, but it already demonstrates how to best bootstrap your sort of out of tree application. Check that out, and heart. Heart emoji as well. Thanks everyone. Subscribe, join us on Discord. Thanks to all our guests. Anas, you keep coming, you keep getting in and out. Thanks everyone. 4.2 is scheduled for some time during the summer, around mid-July off the top of my head. So meanwhile, engage on GitHub, Discord, and talk to you at the next Tech Talk. Thanks everyone.
Thank you. Bye.
Thanks.